Okay, so last week we went through 2.1, 2.2, and a few questions out of 2.3. So what questions do we have out of 2.1 to begin with?
For number 12.
Sure.
So play one of each.
Yeah, we can do 12. Which other ones?
11.
Sure, we can add 11 to that as well. What about 5 through 7, where we had to find the midpoint? Do we need to work out any of those? Any from 5 through 7? Okay, what about 8 and 9, where I give you the point and in the midpoint and you find the other point? Do I need to look at any of those with you? Do we need to look at 8 or 9? Or are those okay? Okay. Sure, yep, we can add 8 to the list. Okay. Any others to look at out of 2.1? Anything else? Okay, what about 2.2? And 2.2 was the slope. Are there some of those that you'd like me to work with you on?
5 and 6.
Sure, we can add 5 and 6.
9.
Yep, 9. Sure, no problem.
And 8.
And 8 as well. Okay. Are there any others out of 2.2 to look at?
15.
15, sure. Is that going to take care of all of those then? We've got time to add more if we need to. Anything else? Okay, what about 2.3? Now in 2.3, I marked that we did 7. We did 14. And I believe we did the entire back page, didn't we? Yep. Okay, so which ones out of those out of 2.3? Now we didn't get through them all. But which ones from 7, 14, and the back page would you like me to go over with you?
14.
Sure, 14. Okay.
7.
Okay, question 7. Sure. What about the back page? Are there any of those that you'd like me to go over with you? Any of those? Okay, and the back page should be very similar to 7 and 14 also, for the most part. Okay, so let's go ahead and begin with these. Sorry about that. Those went down here. My mistake. Those are 2, 3. 7 and 14. Okay, so is that going to take care of most of our questions then? All right, and we can add more to the list if we need to. Let's start with 2.1. Let's look at question 8. And what are we doing in question 8? Well, in question 8, what I give you is I give you the point P, which is 5, 8. And I give you M. Now remember, M represents your midpoint. And then I want you to find the point Q. And Q, we're going to call that X and Y. So that's what we want to find is I gave you a midpoint and an endpoint, and I want you to find the other endpoint here. So the first thing we do is we know this is our midpoint, and we're going to label that P X1 and Y1, and we're going to label Q X2 and Y2. And let's go ahead and write up our formula. So what's our formula for the midpoint? Well, the formula for the midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so that's what we've got there. Now we want to go ahead and fill this in. Okay, so we're going to go ahead and begin by plugging our values in. What about our midpoint? Well, our midpoint, remember that is your m, and that is 9/2, comma, 9/2. And that's going to then equal the x's added together, which is that x1, which is the 5 here, and x2, which is the x, and we'll divide that by 2. And then what about the y's? Well, we know the y1 is 8, y2 is y, and that's going to then be over 2. So is everyone okay with that so far? Now, when we solve this out, what are we going to have to do? We're going to have to solve two equations individually. Okay, so we're going to get two equations, one for the x, one for the y. The comma separates the two of them. Now, the fractions are going to clear themselves out because they have the same denominator. So let's now just focus on the x part, and let's see what we've got here. So on the x part, we have 9 over 2, and that equals 5 plus x over 2. Now, what do we notice about these denominators? Well, these denominators are the same, aren't they? And we could cross multiply, but we don't need to, because since the denominators are the same, then the numerators must be the same as well. So that gives you then simply 9 equals 5 plus x. We can move that 5 over with subtraction. And that gives us then x equals now 4. So that's the x part. Now, what do we do for the y part? Well, we do the exact same process. And on the y part, what do we have? Well, for the y part, we have 9 over 2 again, because that's your x and that's your y component. And that's going to equal 8 plus y over 2. Again, what do we know about these? These denominators are the same. And we could cross multiply, but there's no need to because they are the same. If they were different, you would have to cross multiply. But in this case, we don't need to. So that gives us 9 equals 8 plus y. We'll move that 8 over. And that leaves us then with y equaling now 1. So what does our ordered pair Q look like? Yep, our ordered pair Q looks like 4, comma 1. So does everyone see how that one works? So the fractions clear themselves out because they're the same. As long as the denominators are the same, then we can just get rid of the denominators because it doesn't matter because they are the same. If one would have been a 4 and one would have been a 5, then we would have to cross multiply. But in this case, we don't need to do all that because they're the same. Question 11. In question 11, we want to find the intercepts and then use the intercepts to graph this equation. So we're going to find the intercepts and graph. So our original equation is 11/5 x, thank you, plus 3/5 y equals 6 here. Now, what do our intercepts look like? Well, let's start with the x-intercept. The x-intercept, remember how these work, the x-intercept is blank, comma, 0, and the y-intercept is 0, comma, blank. Now, we need to fill in the blanks for each of these. So we'll have an x-intercept, and we'll have a y-intercept. So let's start with our first one here. We'll do the x-intercept first. And for the x-intercept, what do we substitute in? For the x-intercept, we substitute in y equals 0. And that gives you then 11/5 x plus 3/5 times 0 equals 6. And what do we know about that 3/5 times 0? Well, that 3/5 times 0, that's 0, so it's gone, isn't it? Okay, so it doesn't matter at all. So what are we then left with? Yep, 11/5 x equals 6. And so now we'll clear them out. So we'll multiply everything by a 5 here. It's going to clear out our fractions. And that leaves us now with 11x equals 30. Divide by our 11. And that gives us now our x-intercept to be y is 0, x is 30 over 11. So our x-intercept is 30 over 11, comma 0. Is everyone okay with how I did that? So what did I do to get the x-intercept? I plugged in y equals 0, right? That made that y component go away, cleared my fractions, and then I solved it. And then I rewrote it as an ordered pair, because we found the value of x here. Because x is, just so we know, x is that 30 over 11. Now we're going to repeat the process with the y-intercept. So if I use the y-intercept, that means x is going to be 0. Okay, and then that gives you 11/5 times 0 plus 3/5 y equals 6. And what do we know about 11/5 times 0? Gone. Now what do we have? We now have 3/5 y equals 6. We'll multiply everything by a 5 again to get rid of our fractions. And that leaves you then with 3y equals 30. We'll divide by our 3. And that leaves you with y equals now 10. And so what does your y-intercept look like as an ordered pair? Well, your y-intercept as an ordered pair would now be 0, comma 10. We're not completely done yet. We need to go ahead and graph this, but these are our intercepts. So this is part of your answer here. I'll put a box around it so we can keep track of these. Now we want to graph the line. What do we need to graph a line? Let's review that. When we talk about ordered pairs, we need at least 2 ordered pairs, and they have to be different. So are these 2 ordered pairs, are they different? Yes. So that means we can graph them. Now, how do we handle that 30 over 11? Okay. Just so we know, let's go ahead and rewrite this one to make it easier. 30 over 11, what is that in our calculator? And all we need is 1 decimal place. That's it. Should be a little bit under 3, and it is. Okay, so all we need here is 1 decimal place, and it's 2.7. So as an ordered pair, just to graph it, this would be 2.7, comma 0. And now we've got everything that we need. So 2.7, comma 0. 2.7, well, that's in between 2 and 3, and it's going to be a little bit closer to 3. They do not have to be exact. And I'll go ahead and label this with the fraction. You could also label it with the decimal, but I'm going to label it with the fraction. So there's that point right there. That is your x-intercept because it crosses the x-axis. And then we've got our y-intercept that's going to be up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can connect them together. And make our line. So we've got a straight edge here, so we'll just connect these together. And that is what your line should look like. Is everyone okay with how I did that now? So how did I get the intercepts? Well, I wrote them out as ordered pairs with the blanks. Okay, then I plugged the zeros into each one. I got each one. You're going to get two different points here. Do not just combine them together. Do not write that point, and I see it happen a lot. Students write this, 30 over 11, comma 10, and do not do that. They are separated out. They are two separate points. So do not try and put them together. But a lot of times I see students try to do that. They try to put them together into one point, and you don't have anything. It's not even a valid point anymore. So just be careful of that. That's where students make a mistake. 12. Okay, 12, we need to complete the ordered pairs. So for question 12, we've got all these ordered pairs, and we're going to complete them. So we've got 3x plus 4y equals 12, and we're going to do each one. So we've got 0, comma, blank. We've got blank, comma, 0. We've got 1, comma, blank, and then we've got blank, comma, 2. So we're going to do each one of these. This one's actually a little bit easier because there's no fractions. So our first one, we're going to plug in x equals 0. This, by the way, is your y-intercept when we do that. So we'll go ahead and plug that 0 in. That's gone away. So now we have 4y equals 12. Divide by your 4. And y now equals what? Y now equals, it looks like 3, doesn't it? So there's that. So our first piece is going to be 0, comma, 3 there. What about the next one? We repeat the process again, only this time we plug in y equals 0. So that's 3x plus 4 times 0 equals 12. 4 times 0 goes away. That's gone. So then we're left with 3x equals 12. We'll divide by our 3. And now we've got x equals 4. Okay, we got 2 more here. Next one, we're going to, remember this is your x value, this is your y. So for the next one, we're going to plug in x equals 1. And that is then 3 times 1 plus 4y equals 12. 3 times 1 is 3. So I'm just going to move that 3 over with subtraction. And now we've got 4y equals 12 minus 3 is 9. Divide by your 4. And so y now equals 9/4. Okay, so there's that piece. And we've got one more here. The next one is y equals 2. When I plug in y equals 2, that gives you 3x, right, plus 4 times 2 equals 12. So that's 3x plus 8 equals 12. Move the 8 over. Now we've got 3x equals now 12 minus 8, that's a 4. divide by your 3, and x now equals 4/3. Now I am going to show you a shortcut here. When we go to graph this, we can graph all 4 of the points, but we really don't need to, right? Because we really only need to graph how many? 2, okay? We can graph all the fractions and everything else, but when it all comes down to graphing, we can have more than 2 points, but what do we have to have at most? 2. Or sorry, at least 2. So we've got the at least 2 there. We can graph them all, but we really don't need to, because as long as you've got 2 good points that are easy to graph, then you don't need to graph the rest of them. This is a line. Now, if it was a curve, which you'll encounter in college algebra, you'll have to plot more points. But this one is just a straight line. So we're going to go ahead and plot our y-intercept, which is at 0, 3. And then we're going to plot our x-intercept, which is at 4, 0. And that's going to give us the information that we need to graph this line. Okay, we don't have to graph all the others. You can. There's nothing wrong with graphing all the others, but we need at least 2 points. And we've got the 2 points there. We don't need to graph all the fractions. And why graph the fractions when we don't have to? So again, what are your points? Let me put these up here so you can see the ordered pairs. Those are your actual answers. And that's what your graph should look like. And if you would have plotted all the other points, they'd be in there too. Because 9/4, that's about 2. C would be about 1, up about 2. C would be about there. 4/3 is about 1.3, so it's about 1.5. And up about 2, see it's right about there. Okay, so you could plot them all and they would line up. But you don't need to, because all you need is 2 points here. Did we have any other questions out of 2-1 to look at? Any others to add to the list here?
12 and 13 are the same, right? Equal the same way.
Yeah, 12 and 13 are done the same way. So what you'll do for 13 is you'll line it up exactly the same way that I did. Okay, you'll fill in the blanks just like I did. And then again, all you really need to do is just plot 2 of the points. You can plot all 4 of them if you want, but if you've got fractions, why plot the fractions when you've got other points that'll work better? So 13 is going to be almost identical to 12. (2.2), we'll begin with question 5. And this one, what we want to do is we want to graph it with the point and the slope that are provided. So we're going to now look at question 5 out of 2.2. And what you're given is you're given the point 0, 6. And you're given a slope of 1/2. So there are 3 ways that we can graph a line. 2 points, we can connect them together, no problem. Okay? A point and a slope, or we can graph it from an equation. So we have a point and a slope. So what we do is we begin by plotting our point. That's going to be our starting place. So we're going to start at 0, 6. Which is our y-intercept right here at 0, 6. Now, what about my slope? Well, remember, slope is rise over run. Rise is on the top. It's positive, so we go up 1, and then we go over 2. So this is where we start at. We're going to start right here. Make it look bigger here. So we're going to start right there. at that ordered pair. And what are we going to do? We're going to go up 1 unit, and then we're going to go over 2 units. And we're going to make a new dot. So we went up 1, because that's our rise, and then over 1, 2. We made our new dot, and now we can just connect these together. And there is our graph. So we started at that 0, 6, and we went up 1 and over 2, and that 0, 6 is right here. Let me label it so it's a little bit clearer. Let me put it down here. Okay, 0, 6 is right there, right at that dot. And we went up 1 and over 2. That finished out our line. Question 6. We need to see if these lines are parallel, perpendicular, or neither. And so let's review about parallel and perpendicular lines. When lines are parallel, what do we know about the slopes? They are what? Did someone tell me? Parallel lines have the what? Same slope, okay? What about perpendicular lines? Does anyone remember what those have? They have the opposite what? Opposite reciprocal, okay? So what would an example of perpendicular be? 3 and negative 1/3. Or 5 and negative 1/5. Or minus 4/3 and positive 3/4. Negative reciprocals. And if they don't meet either of those criteria, then what is it? What is it? It's neither one. So let's now look at question 6. And how do we get these slopes? Well, we get these slopes by solving for a y value. And these are currently in what's called standard form. And remember, we talked about this a little bit last time with standard form. So we're going to do each one, and we're going to have to solve each one for y. And then we're going to find the number in front of the x once we've solved it for y, and that's going to be our slope. So let's move that 3x over. And now we have 8y equals minus 3x minus 10. Oh, did I make a mistake? Oh, sorry about that. And that's a negative 8y there, so watch your signs. So we'll divide that by a negative 8 everywhere. And that leaves me then with y equals negative and negative. Makes it a positive 3/8 x. Negative and negative, we'll reduce that down. And that's going to reduce down to a positive 5/4. Now, what's the only part we're worried about? Well, the only part we're worried about is that 3/8. So that's our n for that one. Now, if the other one comes out to be 3/8, then what do we know? Parallel. And if the other one comes out to be a negative 8/3, then they're perpendicular. And if there's something else, they're neither. So easy enough there. We're going to move that 32 over. So move that 32x over. And now we've got 12y equals a minus 32x plus 18. We'll divide by our 12 everywhere. And we do need to reduce these down as much as possible. So we've got 32 over 12. Well, these both have what, a 4 in common, don't they? So if I reduce it down by a 4, then that's going to make it a minus 8 over 3x there. And then we've got the 18 over 12. Okay, 18 over 12, they both have a 6 in common. So that's going to reduce down to be 3/2. So what's my slope again here? My slope is a negative 8/3. thirds. You have to reduce them down first. Before you compare them, you have to reduce them. So what do we know now? These aren't the same, but are they reciprocals? Yeah. If I take 3/8 and I flip it over, what do I get? 8/3. Are they opposite in signs there as well? Yes. So these would then be perpendicular. And why are they perpendicular? Well, they are perpendicular because they are negative or opposite reciprocals. So that takes care of question number 6. Do we see how that works? So you have to reduce those fractions down first. 9 is next on the list. And 9 is another graphing a line when you're given a point and a slope. And this is a very important concept here to understand. It's a simple concept, but a lot of times students struggle with this. So we're going to try and graph this. And what we're given is we're given 9, 0, and m equals -1/3. Okay, now, where are students most likely to make a mistake? I guarantee you that someone will say 9/0 is clear up here. Is 9/0 clear up here? No, be very, very careful. Remember, this is your x value. This is your y value. So 9/0 would be clear over here. Okay, 9/0 is right here. Not on the y-axis. It's on the x-axis because that's where 9/0 is. A lot of times, though, students will make a mistake and put it up here. Just because you get in a hurry and you think it's a y-intercept, but it's actually the x-intercept. Now, what is my slope? -1/3. So what are we going to do? Down 1, and you always move to the right. So you're going to go down 1, and then over 1, 2, 3 units. And this, by the way, is where we started at. So that's where we're starting. We went down 1, and we went over 3. And now we can connect these together. So all you need to do is plot your point first, and then go down 1 from that point and over to the right 3. Always move to the right, never to the left. And let's see, did I skip 8? Yep, I must have forgot to do 8, so we'll go back and get 8. I actually forgot to get 8. Well, do we need to do 8, or does it make sense what to do now? Do we see how we would do 8? Because I think we've done a couple of these. What do we do for 8? We plot that point, 0, 4, right? And then we're going to go down 1 and over 2. Make another dot and connect them together. So question 8, I don't think you really need to go back and do, because we've done 2 of these already.
So it's always to the right.
Always move to the right, yep. Because if you have a double negative, that double negative will make it positive. So the bottom half is always positive, which means you always move to the right. Now, if it's negative on the top, what does that mean? Down. And if it's positive on the top for your slope, what does that mean? Up. Okay, but you always move to the right, never to the left. Because we did 2 of those, because we did 5 and we did 9. So they're very similar. And 15, I believe, is the last one to look at here. And 15, we have to be careful about with the double negatives. So for 15, we've got a partially completed slope. And we need to work it out. Just get these organized here. we need to work it out with those double negatives and end up with our slope. So get these organized here, and then we'll look at 15. For 15, we've got 7 minus a minus 3 over 2 minus a minus 0. Now, when we work out these slopes, a lot of times you're going to end up with a double negative. And whenever you have a double negative back to back like that, what does that then become? Positive. So we've got double negatives in the numerator and in the denominator. So the numerator is now 7 plus 3, which is 10. The denominator is 2 plus 2, which is 4. And you always want to reduce that down as far as you can. So 10 over 4 then reduces down to 2 over 5. Is everyone okay with that one now? Want to see that one? Okay. 2.3. We only asked about a couple of questions, which were 7 and 14. So let's look at 7. And they're all pretty much the same for these. Now, when we go to look at these, let's take a moment to remember our slope-intercept form. Now, slope-intercept form is y equals mx plus b. And that m, well, that is your slope. And the b, well, that is your y-intercept. And as an ordered pair, that is 0, comma b there. So for 7 and 14, what we're doing is we're going to plug in our values. We're going to get it in slope-intercept form. Now, 7 is slope-intercept. 14 is standard. So for 14, we'll have to do an extra step. But for 7, we want it in slope-intercept. So for question 7, what we have is we have m equals a minus 4/3. And we've got our y-intercept of 0, comma 26/3. What is this? This is your b. And how do I know it's a y-intercept? Because it tells me. And also, that's 0. If that's 0 at the beginning, that automatically is a y-intercept. So we can go ahead and fill this in. So we've got now y equals m, which is minus 4/3 x. And we've got our y-intercept, which is the b component, which is 26 over 1. 26 over 3. And that's all you need to do. Fill in the components where they belong. Because that's your y-intercept, which is the b. And m is your slope. Now today, we're going to be looking at some others where we have to do a lot more work. Where we have to work with something that doesn't have a 0 there. If it's got a different number than 0 here, then we have to do a different process. But as long as it's 0, comma some number, we can jump directly to our answer. So let's move on and look at 14. Now 14, we want our answer in standard form. So for question 14, we want the answer in standard form. And for 14, we've got this point, 0, comma 5. And then we've got a slope of 2/5, and it's negative. Well, first off, let's look at that first point. that, or not that first part, that point that they gave me, that is a y-intercept. How do I know that this is a y-intercept? Because the x value is 0. So as long as the x value here is 0, as long as it starts with a 0, see, this then is your y-intercept. So now in slope-intercept form, what is it going to look like? Well, in slope-intercept form, just like the last one, it looks like y equals a minus 2/5 x plus 5. Because slope-intercept form, remember, is y equals mx plus b. And that is your b right here. That 5 is the b. However, we are not done. Because this one specifically says, write the equation in what? Standard form. Now, in standard form, can we have any fractions? No. And let's just write up quickly what the standard form is. So we remember what standard form looks like. So we remember here. We covered this a little bit last time. Standard form is ax plus by equals c. No fractions or decimals. And a must be positive. These are capital letters, and that tells me that they're going to be integers. So that's what. As long as they're capital letters, that means we can't have fractions. So let's now make sure our answer is in standard form. And so no fractions, so we need to take care of those. So we'll multiply everything by a 5. That will clear out my fractions. And that leaves me with 5y equals now a minus 2x. And don't forget your 25 there, because that 5 has to be distributed through. Now what can we do? Well, it's not quite in standard form. To get this in standard form, we're going to add that 2x over, and now we've got it. So now we have in standard form 2x plus 5y equals 25. And that is in standard form. And how do I know it's in standard form? Well, it starts off positive with that positive 2. And no fractions and no decimals. X and y are both on the left-hand side. Okay, are there any other questions to look at? If not, then we'll go ahead and take a short break. And then we'll come back. And we'll finish up 2-3. 2-3 is a really complicated section. So let's take a short break. And we'll meet back here, let's say at 9:35. So that gives you about a 15-minute break. We'll come back. And we'll work through 2.3.